Hello everyone. Today we're going to learn how to write a noble gas configuration. A quick reminder, electron configurations are a way of keeping track of which orbitals electrons are located in. For example, the electron configuration of the common sodium ion is 1s2, 2s2, 2p6, because the common sodium ion has 10 electrons in it. However, electron configurations can get very long very fast, and so a shorthand method would be handy to have. The name of the shorthand method that is most commonly used is the noble gas configuration. In the noble gas configuration, the core electrons, those who have the lowest energies and are closer to the nucleus, will be substituted using a noble gases symbol in brackets. For those who do not know, the noble gases are the members of the 18th column on the far right of the periodic table. These are helium, neon, argon, krypton, xenon, radon, and unobtainium, a theoretical element that is man-made. So, let us see the steps that are involved in this by writing the noble gas configuration for phosphorus. Our first step will be to find who the noble gas we're going to use is. We want to select a noble gas whose atomic number is a little bit less than phosphorus. The most convenient way to do this, if you have a periodic table handy, is to go up one period or row and go over to the far right to find a noble gas. If you do not and only have atomic numbers, you'll just look for one with a slightly smaller atomic number. Since there are two noble gases that are close to phosphorus in number, we have neon, number 10, and argon, number 18. We should pick neon out of these two since we want one that is smaller than phosphorus, who has atomic number 15. So neon's symbol in square brackets will be part of the noble gas configuration for phosphorus. We then need to determine what the rest of the configuration looks like. In order to figure this out, we need to figure out what orbital the noble gas's configuration ended with. In this case, that means we have to figure out what neon's configuration ends with. Neon is atomic number 10 and has 10 electrons. Its configuration is 1s2, 2s2, 2p6. This is the portion of the electron configuration that will be substituted by putting neon's symbol in brackets. So it ended in 2p6. The next thing is to determine what orbital will come next, because we have to represent the electrons that are different between neon and phosphorus. Since neon ended with 2p, the next orbital that should be filled is 3s, and so the remainder of the configuration for phosphorus will start with 3s. So let us now start writing the configuration and filling in the remaining electrons. Phosphorus is equal to neon in brackets, which accounts for the first 10. Then 3s2, because there were 5 remaining electrons. There are now 12 electrons represented in this configuration, 10 with the neon and 2 with the 3s2. There are still 3 more that need a home. After 3s comes 3p, and we can put the remaining 3 into the 3p. So the complete noble gas configuration of phosphorus is neon, 3s2, 3p3. Let us write the noble gas configuration for silver. Silver is atomic number 47. Since it's atomic number 47, we will use krypton, atomic number 36, as the noble gas that we will substitute for silver's core electrons. That means that we will use Kr in brackets, and there will be 11 more electrons to place outside of the first 36. Since krypton's configuration ends with 4p6, the next available orbital will be 5s. So for the remaining 11 electrons of silver, they will start filling with the 5s orbital. Silver's noble gas configuration is krypton 5s2, 4d9. Let us write another example using a member of the F block. Write the noble gas configuration for uranium. Uranium is atomic number 92, and so we will use radon, atomic number 86, as its noble gas. That means that there are 6 additional electrons that we must find homes for. Radon's electron configuration ends with 6p6, and so the next available orbital will be 7s. Uranium's noble gas configuration is radon 7s2 for F4. You may have noticed the noble gases usually end with p6, which means you're usually going to continue and start up your noble gas configuration after the noble gas symbol with some sort of s orbital.